everybody, page 398 in your book, Key Concept.
No choya wood here.
There is no choya wood on this. No choya wood. There's no dowel rods on this either. Okay? Here we go. What types of problems can be solved using the Pythagorean theorem? A. Any problem that has a 90-degree angle.
Looking for right triangles, folks.
How about that? Okay?
Yep.
If we can create a right triangle, that's where we talk about, hey, rectangles, can you create a right triangle out of a rectangle? Absolutely. If we got a 90-degree angle, there's a good chance we can make a right triangle. Okay? Mr. Fricke said we're allowed to skip number 2 and number 3.
Garbage.
Okay?
Garbage they
so
are.
Let's go to number 4. I love painting barns. Okay? In fact, this is not a barn. It says this is a shed. Okay? You're going to place the base of a ladder 12 feet from the shed. See, ladder's 12 feet away. Ooh, this thing is 35 feet tall. Wow, that's pretty tall. Better get a long ladder.
Yeah.
How long does the ladder need to be to reach the roof? Well, let's take this thing.
That looks like a right triangle.
Here, okay, there's a right triangle. Okay, this is 12. This is 35. We need to find this side. Is it going to be more or less than 35? It's the hypotenuse. It's going to be more. So let's find, okay, using the Pythagorean theorem, a squared plus b squared equals c squared. Okay, a and b, 12 and 35 equals c squared. Well, square them, add them together. Let me grab my handy-dandy little calculator.
So 144 plus some large number.
35 squared is going to be pretty big.
925?
200.
Oh.
And 25. 1225.
That's way off.
Okay, there's the squares of those two sides. Let's add them together. Now we got 1,369. Holy smokes. That ladder's got to be 1,369 feet.
No, it doesn't.
No, find the square root of both of those. That's going to tell us the square root of 1,369 is, a cool 37 feet. Okay? That ladder has to be 37 feet long. I don't think Mr. Fricke would like to get up there.
Nope.
And I know Mr. Knoll from Walker, Crazy Mr. Knoll, guitar guy, he would not.
Nope. I'm out.
He would not do
I'm
that.
out.
I'd do it. I wouldn't like it very much. All right, number 5. A box shaped like a rectangular prism measures 5 centimeters by 3 centimeters by 2 centimeters. What is the length of the interior diagonal of the prism to the nearest hundredth? Okay, this goes back to what we did in example 2.
Draw a picture, folks.
Okay? Let's draw. Here's my best drawing of a rectangular prism. Start with a square. Okay, rectangle, whatever you call it. Try and draw another one, just about the same size. Connect bottom right-hand corner to bottom right-hand corner. Top right-hand corner to top right-hand corner. Top left to top left. Bottom left to bottom left. And we created a
That is terrible looking.
That's terrible?
That is
That's
garbage.
the best I can do.
Okay.
Do your best and forget the rest.
That's right.
5 centimeters by 3 centimeters by 2 centimeters. Now this is where we got to find the hypotenuse of the base. So first thing, if I think about it, and I'm going to trace what I look at and see the bottom part of this, I need to find the length of this diagonal, which this diagonal, first triangle, has a 5 centimeter side and a 3 centimeter side. Find the length of that hypotenuse. Okay, a squared plus b squared equals c squared. 3 squared plus 5 squared. Okay, well this is 9, this is 25. 9 and 25 together, that's
34.
34. So to find the length of this hypotenuse, we got to find the square root of 34, which if you remember your perfect squares, 36 is a perfect square. So I know this is going to be a little bit less
Then 6.
So let's find the square root of 34. looks to me like it's about 5.83. 5.83 approximately. So I'm going to give the wavy equal sign 5.83. Okay, are we done? No, because now we need to find the length of the interior diagonal. Okay, and let me make this green so we can see a little better. So from this bottom corner to its opposite corner. Okay, so we have this triangle. Okay, now if I drew this triangle over here, boom, my right angle. Now I know this leg right here, 2 centimeters. What was the length of this side? That's what we just found. We just found. Okay, so this length is approximately 5.83 centimeters. We have to find the length of that diagonal once again. So let's do it. Okay, a squared and b squared. So 2 squared plus 5.83 squared equals the hypotenuse squared. Square them and add them together. So let's go. 5.83 squared. I'm going to just round that off, if that's okay. This is 4. 5.83 squared, I'm going to go with 33.99. Add them together, that makes 37.99. Final thing, okay, what do you got to do? Find the square root of 37 and 99/100. Square root 37 and 99/100. Oops, wrong button. 37 and 99/100. This comes out to be approximately 6.16. Remember, approximately has the wavy equal sign. We are talking about centimeters. Bingo. There you go. You like it?
Love it.
Okay. Well, let's go to number 6. A wall. Ooh, a wall. Good old wall. 12 feet long makes a corner with a wall that is 14 feet long. So we've got a wall making a corner with another wall. This 12 feet, this 14 feet. It says the other ends are about. So this end and this end, the distance it is saying is 18.44. Now it uses the word about. Okay, be careful here. It says this is about. So, do the walls form a right angle? So we need to see, does a squared plus b squared equal about c squared? Because it says about. So, a squared plus b squared equals c squared. This goes back to 7-2. A and b, there's my right angle, because those are the two walls that form a corner. 12 squared plus 14 squared and 18.44 squared. Well, let's square them and add them together. 12 squared plus, 12 squared plus 14 squared. That's 340. Is that about equal to 18.44 squared? So let's do it. 18.44 squared. 340.03. Okay, and I'm rounding that off to the nearest hundredth. Well, are those about the same? Yeah.
Yes.
Do they walls form a right angle? Yes. Okay, my explanation right there.
Is the math.
Okay, that takes care of 7-3, key concept. Mr. Frankie's going to catch you for the great and wonderful additional practice.